All right, welcome. Today, we are taking a tour of the single most important chip inside your computer. You can think of it as the brain, the boss. Really, it's the part that does all the heavy lifting. We're going inside the CPU. Every time you click your mouse or type a single letter or even just watch a video, there's something in there making it all happen. And that something is the central processing unit, or CPU for short. So let's think of it as the brain of your computer, and we're about to get a special inside look at this incredible factory. So here's our roadmap for the tour. First, we'll officially meet the computer's brain. Then we'll check out its main production line and all the internal departments. After that, we'll look at what actually makes it fast, and we'll wrap up with a little cheat sheet so you remember all the key terms. Okay, first stop on our tour, let's get a proper introduction to the star of our show. What exactly is a central processing unit? Well, what it really boils down to is this. The CPU is the boss. It's this tiny but incredibly powerful chip that executes every single command and does every single calculation. From the simplest little game to the most complex video editing software, literally nothing happens without the CPU getting involved. And that's why it's so important. So, now that we've met the boss, let's see how the work actually gets done. We're heading over to what you could call the main production line of our little factory, and it's a process known as the fetch, execute cycle. This whole production line is this simple, but honestly, brilliant three-step process. First up, fetch. The CPU goes out and grabs the next work order from the computer's memory. Step 2, decode. A manager inside the CPU reads that order and figures out what it's asking for. Something like, add these two numbers. And finally, execute. The CPU just does the task. It's that simple, right? Get the order, understand the order, do the order. Now, here's the part that's truly mind-blowing. This isn't just happening once in a while. This fetch, decode, execute cycle is a non-stop loop that runs, and I mean this literally, billions of times every single second. That incredible speed is exactly what makes everything on your computer feel like it's happening instantly. Okay, so we've seen the main production line chugging along. Now let's meet the different departments and the specialized workers inside our CPU factory that make all of this possible. So any good factory has its key departments, right? Well, inside the CPU, you've got three main ones. First is the Arithmetic Logic Unit, or ALU. This is basically the calculator. It handles all the math and all the logical comparisons. Next up is the Control Unit, or CU. This is the manager. It's directing the flow of data and telling everybody else what to do. And finally, you have cache memory. Just think of this as the quick notepad, a small but super fast bit of memory for storing things the CPU needs to get to all the time. So, we've got our main departments. But for the work to get done really smoothly, the workers need their tools and their instructions right at their fingertips, right? Well, that's where registers come into play. They are these tiny, ultra-fast storage spots located right inside the CPU itself. And as you can see here, each register has a very specific, specialized job. For instance, the program counter is kind of like a to-do list, always pointing to the very next task. Meanwhile, the accumulator is there just to hold the result of a calculation. The main takeaway here is that these super fast little storage spots make sure that the whole production line runs without any delays at all. Okay, let's cover a quick but really important concept, the difference between an address and data. And this analogy here is perfect. Think of an address like a house number. It just tells you where something is located in memory. The data, on the other hand, is the actual stuff inside the house. The furniture, the people, the information itself. The CPU has to know both where to look and what it's looking for to do its job. All right, so we know how the factory works, but what makes one factory better or faster than another? Let's talk about what makes a CPU more powerful. So, what's the secret sauce for a high-performance computer brain? Well, it really just boils down to three key factors that decide how quickly and how efficiently a CPU can get its work done. First up is clock speed. The best way to think about this is like the tempo, or the beat of the entire factory. It's measured in gigahertz, which means billions of cycles per second. So a higher clock speed means that fetch-execute cycle we talked about happens more times per second. More ticks of the clock means more work gets done, which leads to faster performance. Simple as that. Second on the list is cache size. Remember our quick notepad from earlier? Well, the bigger that notepad is, the more of that frequently used information the CPU can keep right next to it. And this is so important because it means the CPU spends way less time waiting around for data to arrive from the slower main memory. A bigger cache almost always means a faster computer. And number 3 is the number of cores. Now, this one was a real game changer. The easiest way to think of a core is as an entire independent processor. So a quad-core CPU is like having 4 separate production lines inside your factory, all running at the same time. This is absolutely key for multitasking. But there's a balance. Some things, like a lot of video games, still really rely on the raw speed of a single core, while other tasks, like video editing, will use every single core you can throw at them. Whew, okay, that was a lot to take in. So before we finish up our tour, let's do a quick rapid-fire recap of the most important terms we learned today. Think of this as your personal vocabulary cheat sheet. Okay, let's fly through this. First, the CPU, the central processing unit. That's the brain of the computer, the chip that runs the whole show. Its main job is to run the fetch-execute cycle, that constant loop of getting an instruction, figuring it out, and then doing it, billions of times a second. Inside the CPU, you've got the control unit. That's our factory manager, directing all the traffic. And you've got the ALU, the arithmetic logic unit, which is that powerful calculator that handles all the math and decision-making. And I'll leave you with one final thought to chew on. The CPU in the phone that's probably in your pocket right now is millions of times more powerful than all the computers NASA had combined for the Apollo moon missions. We've just taken a tour of how this incredible little brain works. The only question left is, what amazing new thoughts will it help us think up next?